Here's a small jar of clean tap water, and here is the ammeter, and here's the 12-volt battery, and here's some aluminium electrodes that we're going to use to clean the water. Here we've got some garden soil and some clean water, and for the first experiment we will just shake this up, make a very murky, nasty looking water, and we'll just pass it directly through a filter. In this case it's a piece of kitchen paper, and that's good enough. But as you can see, the very small particles are passing directly through, and we've got the filtered water, which is very murky and very unappetizing, and really I wouldn't like to drink it. The other thing is all the bacteria in the soil particles, imagine it's like river water, are also passing through the paper, and they'll be inside this water, and they'll make you pretty ill if you drink it. So this is the problem with drinking untreated water. Now we're going to repeat the experiment. Again, garden soil, shake it all up. Very murky, horrible, nasty, yucky water. Wouldn't like to drink that, that'll make you pretty ill. And this time we're going to treat it using electricity and the aluminium electrodes we saw earlier. We're going to pass the electricity through the electrodes, so we put them directly into the yucky water. The power's already on, we're drawing 1.4 amps, and if you look closely you can see some fizzing starting to occur in between the plates. I'm just giving it a stir because in a bigger plant we'd use a pump to pass the water over the plates, and we can't do that here because the reaction takes place between the plates. So we'll give it a few more moments, continue to let it fizz away. The electricity, it's a DC current, it's passing from the anode to the cathode, and one more stir and I think we're probably there, just to make sure we've treated all of the water, and we'll just give it a few more moments. Yep, the current has now dropped to 1.3, and if we continue to treat it the current will drop further down. But really I think we're about done now, so we'll turn the power off, take the electrodes out, and as you can see actually the water's already separated. The lighter particles are floating and the solid heavier ones are sunk to the bottom. So we'll just take this entire mixture, this entire jar of water, yucky water, pass it through the same kitchen paper filters. As you can see, in this case the filter's struggling a bit more here because it's actually having to remove all of the silts and the solids that have now collected and separated from the clean water. But as you can see, the clean water the water coming through the filter is absolutely clean, and the benefit of passing the electricity through the dirty water is that you actually electrocute all the bacteria and the viruses, you rupture their cell structures, and you effectively disinfect the water, a bit like perhaps putting chlorine in, which would kill the bacteria. So the bacteria are very tiny and will actually pass through the filter paper, but because they're dead, they're not going to cause you any harm when you drink the water. A bit like normal water in the tap is disinfected with the chlorine, we've disinfected by electrocuting them. Now, here we have the final results. The first on the left is the dirty, yucky filtered water, and on the right here, me shaking it, is the lovely, clean, electrically treated water, which is disinfected and will make perfectly acceptable emergency drinking water.